Okay, so what I ask is everybody just draw this picture and then sketch a polynomial function corresponding to this picture. Implicitly, and I didn't state it explicitly, but implicitly, these are the only points where the function can go through one of the axes. Okay. Okay, so, well, most people have drawn a graph that looks pretty much like this, maybe a little different. This is a little lopsided. Your graphs are probably better than mine. Okay. Doesn't matter. Now I did ask you to put numbers on these points. Okay. So I'm going to put my own numbers here, but you've got yours. Okay. So I'm going to say, oh, I'm going to say that, let's see, this number is, at this point is minus 9, 0. I'm going to make this point 8, 0. And I'm going to make this point, well, if that's minus 9, this is either going to be minus 5 or minus 6. I'll say minus 5. It's probably more like minus 5.5. Okay. So I've got coordinates in these points, and now I want to put a coordinate on this point. Okay. Everybody hold up the number of fingers you want me to use for the coordinate of this point. Just hold up some fingers. Okay, so I got a 10, and what else have I got? 2 10s and a 3. That adds up to 23. So I'm going to call this 0, negative 23. Okay. So nobody got their choice, but everybody contributed to it. So everybody happy? Okay, everybody's kind of smiling, or nobody's looking very threatening. Okay, so I'm happy. All right, makes me more comfortable. Okay, so now my question was, now that you put numbers on it, can you write the formula for this function? So we'll discuss this for a minute, see if there are any ideas. Okay, now somebody made a really nice observation that this is kind of like a cubic function. Okay, starts down here, kind of levels off and goes up. Could be a different odd degree, but it would be an odd degree function ultimately. So it would be a polynomial of odd degree. Well, in this case, we have 3 zeros, and the graph goes through each 0. If you look at it microscopically near this point, this is like a straight line. Just if we just do a couple of millimeters around this point, it's like a straight line through the x-axis. Okay, same here, straight line here, straight line here. Okay, from that we conclude, okay, well, first of all, well, I say the general form of a polynomial, and I'm going to change my word. Because what you call general depends largely on what you're doing. I'm going to call it, I'm going to be specific. The factored form of a polynomial is y equals p of x equals some number a times x minus, let's call it for 0, z1 times x minus z2 and so forth up to x minus z sub n. And I could even say now this is a polynomial of degree n, because if I multiply all these out, you're going to get an x from every factor, and there are n of them. Now, do we understand the notation? This is z1, this is z2. I've got 3 dots, which I probably ought to make easier to see from the back of the room. And this is x minus z sub n. So if n was 10, you'd have an x minus z1, x minus z2, x minus z3, x minus z4, all the way up to x minus z9 and x minus z10. Does that make sense? So we need to understand that notation, understand what I just wrote down. But the idea is fairly simple. In this case, you only have 3 zeros, and they're all linear. Okay, so we have 3 linear zeros. Leave myself room. Okay. A times x minus z1 times x minus z2 times x minus z3. Specifically, we'll do the zeros from left to right. This will be a times x minus -9. Okay. And that's multiplied by x minus -5, and that's multiplied by x minus 8. So that's a times x plus 9 times x plus 5 times x minus 8. Now that's a formula you can follow, but why does that make sense? Well, does this graph go through -9, 0? Show me in your paper how you know that the graph goes through -9, 0. That the graph of this function has to go through the point -9, 0. Okay, people making a little progress here, but still kind of stuck in how to get started. So the question is, and put it in writing. Just kind of read that for a minute and see if just seeing it in writing gives you an idea. Okay, so, well, why do we know? According to the formula for P of x, if x equals -9, what's y? Okay, well, x equals -9, y equals P of -9. Okay. Which equals a times -9 plus 9 times -9 plus 5 times -9 plus 8. Now, actually, as soon as you got -9 plus 9, since all these are multiplied, you know you're getting 0, right? I didn't leave myself room to write that, but I say, so negative 9, 0 is on the graph, as it must be because there it is, okay? So far, the function matches the picture. I'll just make a little note. Okay. Well, does this function? I'll write it a little bigger because some of you have a little trouble seeing it. I'll write it kind of big here. P of x equals a times x plus 9 times x plus 5 times x minus 8. There. What I claim we know about this function. If it's going to be of this form, a bunch of x minus this, x minus that, and x minus that, one of those things has to be x plus 9, so that it'll go through the point negative 9, 0. Okay. Well, can you write out the rest of the function? Except, of course, for a, we don't know what that is yet. Okay. So what else can you fill in? What do we now know about the function? P of x equals what? Again, we're discussing it. The question, why did I write x plus 5? Why did I write x minus 8? And what would you write for your own function? Can you write out the formula for your own function? Again, a remains unknown, but we're going to use the y-intercept to figure out what a is. We'll do that in another step. Let's write it out for the numbers you chose and see what we have. Okay, now it appears that everybody understood this, at least by imitation. Make sure we understand the reasoning. If you're going to have a 0 at, let's say, x equals 12, your polynomial has to have an x minus 12 in it. Otherwise, it's not going to be 0. Okay? So you've got your 3 zeros, and you've just used them instead of the 9, the 5, and the negative 8 that I used. You use your own numbers. Okay? So I think everybody's got that. They still got that a in front of it. So let's consider what the y-intercept tells you. Okay. Of course, I don't have any more room here, but let's do it this way. And now if what's our conclusion if x equals 0? We have the point 0, negative 23. What's that suggest that you might do? Some of you have already done it, but let's make sure everybody's up to speed here. See how we do. Let me emphasize that it's kind of important to write things out logically. In other words, I write if x equals negative 9, what is y equals p of x? Then I make the statement, if x equals negative 9, then y equals p of negative 9. Okay? Now, I don't see people writing out the logic. I see people shortcutting the logic, which the logic can confuse things a little bit, but once you understand the logic, it clarifies things a whole lot. Okay, so think about this. Now, if I write down the logic, if x equals 0, then, okay, there are two things that we can say. Then y equals p of 0, in the case of my function, is a times 0 minus 9 times 0, h star 0 plus 9, 0 plus 5 times 0 minus 8, which is, I multiply it out, I think it's 360, pretty sure, negative 360. Okay. So there's a logical statement that tells me everything I need to know about where this came from and what the assumption is. Okay. Now, another thing we can say is from the graph, my graph, if x equals 0, then y is negative 23. Now, not everybody's paying attention to what I'm saying here, so I'm going to wait till I have everybody's attention. So what I just said is incredibly important. I don't mind you, letting your mind go where it wants to. And that's fine. I'll be patient with that because I want you to do that. Okay. But I really need to draw your attention to this. Now, look here. This is very, very, very important because there's one thing that most of you seem to be missing here. Okay. Okay. If x equals 0, then we get y equals negative 360. There's a glitch on the board there. It made it a little hard to write that, but then we have it. Okay. So if x equals 0, we use the function. We've got the function. It's got a in it. You don't leave a off because you're focused on this. It doesn't give you the doesn't make it a good idea to forget about the a. Okay, if you don't have the a, you can't solve this. And of course, you know what I just did? I forgot about the a. It's negative 360a because I was busy verifying my calculation there. Okay, so if you left off the a, we're even because I left one off. Okay, it's not the end of the world, but you got to go back and make sure you've got everything. All right. Well, now, from the graph, if x equals 0, then y is negative 23. Now, why did I say that? Well, I looked at the graph. This says if x is 0, y is negative 23. That's exactly what this ordered pair is telling me, right? So why don't you write out this statement from the graph, if x equals 0, then, and write out all the logic. Okay, so we have, again, this is extremely important. Try to focus on what I'm saying here. Of course, you can always go back to the video, but it's better if you focus on it now and get the epiphany while you can. We have two things that are true. If x equals 0, then we have this. If x equals 0, then we have this. Now this says that y equals negative 360a, and this says that y equals negative 23. So what does that suggest? If y equals this and y equals that, what can you conclude? Okay, so this is extraordinarily important. This goes back to principles that you learn starting in pre-algebra, but don't really learn because you don't have to know the principles in order to pass an SOL test. Okay. The principles are the thing that makes it easier to learn the algebra. Okay, here's where we have it. Okay. So x equals 0, then y equals negative 360a, and y equals negative 23. What does this tell you? Okay, now what I just said is what's our conclusion here? And I picked two members of the class and I said, okay, if it's almost Halloween, if you dress up to look like me and you dress up to look like me, then what do you look like? And the answer was, well, you. Okay, me. Okay, and what do you look like? Well, that's me. Okay, so now what do you look like? Oh, her. Okay, and what do you look like? Oh, her. Right. If you both look like me, you both look like each other. Now, again, that's something nobody in their right mind would actually do. But same principle here. Okay, if y equals this and y equals this, then we have this, and it's an application of a principle. Now, you're going to learn to do this, but do you learn to do this as an application of a principle, or is it just something you do in this case where there's a graph of a cubic polynomial? Okay. And when people learn mathematics, they learn this in connection maybe with a cubic polynomial, but they don't learn this as an instance of when two things are equal, each equal to another thing, they're equal to each other, which is one of your basic principles that I believe is taught right at the very beginning of any algebra course, but never really taught in a way that makes the principle clear. It happens again and again, but nobody really understands it in terms of the principle because it's one of those things that I'll bet is never tested on an SOL, and everybody knows it's not going to be tested. Okay, well, enough about the philosophy of the thing. There it is. And it's not the simplest principle to understand, it's probably why they don't test it. Okay, not what they should do. Okay, anyhow, this can be solved for A, right? Solve this for A, we have our formula for P of X. Okay, so what do you get when you solve my equation for A? Okay, what's my function? What's your function? Well, that's a decimal equivalent. You're better off using the fraction and then approximating it. But that's fine. I'll just solve it for you. What for your function? What is it for your function? Okay, so now some people wrote out a decimal equivalent of this. Okay, in the most cases, we got 0.06. Generally, if you're going to do a decimal equivalent, the rule of thumb is do 3 significant figures. I think one person did got 0.0639. That's more accurate. 0.06 differs from 0.0639 by over 6%. Okay, close to 7%. So you don't want a 7% error because you didn't use enough significant figures. Now, sometimes 3 significant figures is overkill. Sometimes you need even more. And that's a topic we're not going to talk too much about in this course. It's a good topic for calculus course, but doesn't usually get the emphasis it deserves on calculus course either. In science courses, you kind of get it. Okay, anyhow, so P of x equals what? Well, P of x is a times x plus 9 times x plus 5 times x minus 8. That's going to be 8. Well, a, which is 23 over 360 times x plus 9 times x plus 5 times x minus 8. Okay, so in less than an hour, we've completed this exercise. Another way of saying that is we took a whole hour to do this, but hopefully we've done it in such a way that you understand it better than you would if you were simply imitating it. And in your pre-calculus class, you're going to find that you need that sort of understanding. Now I'm going to do something else. I'm going to do it more quickly than I'd like to because there's some other things that we need to look at. Whoops, that one's been used. Okay. Hang on a second. Okay. If I draw the same thing. Okay. But now I say the graph is up here and it's up here. How are you going to draw that graph? Well, you're going to want to come down through here and up through here, but if you do, you're stuck because you can't get back here. Because you can't go through the x-axis again, assuming that these are the only zeros, okay? So what you're going to have to do is you're going to either have to turn around at this point or at this point. So there are 2 ways you could draw the graph. You could draw it like this. Or maybe you would choose to draw it like this. Something like that. I didn't do a very good job here. My zero doesn't look exactly right. You get the idea. I could turn around here or I could turn around here. Okay, well, using the same numbers, so that this point is -9, 0. This point is -5, 0. This point is 0, -23. And this point is 8, 0. The flight graph. Would be this. Whoops. Be this. Okay, because the white graph turns around at -9, so it behaves like a little parabola near this point, okay? Then you get a parabola if you take the x² function and shift it 9 units to the left. And you would understand that x plus 9 squared shifts the x² graph 9 units to the left. That's also multiplied by a and by whatever x plus 5 and x minus 8 give you when x equals -9, okay? So it's going to be a vertically stretched graph, but it's going to be a square graph. If you could take the blue graph but we want to distinguish these. We don't want to call them both P of X. We'll call this P1 of X. We'll call this P2 of X. All we have to do to finish the function is find out what A is. How do we find out what A is? We plug in X equals 0 and Y equals -23. And to complete this, I really should write Y equals okay? So for the P1 graph, I just plug in 0 for X, and I've got to get -23. Well, 9 squared is 81, that's 405, and that's 3,240. Little question mark there, I did that quickly in my head, okay? And it's -340A. So A is -23 over -3240. And P1 of X equals -23 over -3240. And since both of these are negative, I can just make it 23 over 3240, and then it's times X plus 9 times X plus 5 times X minus 8. It's very quick and very simple. Okay. And then for P1 of x. We could plug in 0 for x, -23 for y. We have y equals a times this, so we use y equals and plug in 0 for x, plug in the value of y. That's going to be a times L25 times 8 is 200, so that's 1800. And we get a equals 23 over 1800. So P2 of x equals 23 over 1800 times x plus 9 times x plus 5 squared times x minus 8. Now, if you know how to use a graphing calculator, which I don't emphasize in this course, you can actually plot these and see what the graph actually looks like. We go to Desmos online or whatever, if you know. Those things are very easy to use. So if you want to convince yourself, you could, I'm not going to show you how to use your calculator. Don't teach that because I don't require it. Okay. But you can easily go to the Mark Tutoring Center over in the library. Okay. And somebody will show you. If you have a calculator, or if you want to do it on the computer, it can be kind of instructive. Okay. I'll also comment that if you don't have the y-intercept, if I gave you the coordinates of any point on the graph, you'd have an x and a y. If you have an x and a y, you can plug y in here and x in here and solve for a. So that's a very important point. And Open Math is going to show you that. Okay, now we need to move to another topic. Okay, I'm going to demonstrate long division with a simple example. And I'm just going to show you the mechanics. I was hoping to have time to show you why the mechanics work, because sometimes you know the mechanics better, but I'll probably talk about that in pre-calculus class. Okay, so your procedure here is you take the leading term here, the highest degree term, and you divide it into the highest degree term here. So how many times does x go into x squared? It goes in x times. How do you know that? Because if you multiply x by x, you get x squared. And if you multiply then x by -7, you get -14x. Which means that if you multiply x minus 7 by x, how much of this polynomial do you have? You have all of what you have here. What you lack is what you have here minus what you have here. So what we need to do, you might not understand that, but we need to subtract all of this. Okay. Now, instead of subtracting all of this, I'm going to distribute a minus sign through here. I'm going to put a little minus on the x squared and a little plus on the 14x. I'm not going to change the sign of x squared into minus. I'm not going to change the sign of 14x to plus, but I'm going to write a reminder a little tiny minus sign here and a little tiny plus sign here to remind me that when I subtract these from this, I've got to add a negative x squared and a positive 14x. So this gives me 0 plus 26x. Also got the minus 5. I could have written the minus 5 here because I'm still only subtracting this much. I still got the minus 5, so I've still got it here. A lot of times we just skip writing it here. We just understand that we could have written it here, but we don't bother writing it until we get down here. So if that confuses you, there's an explanation to confuse you a little further. Okay. Now, we divide x into 26x. Well, that gives us 26. How do I know? Because 26 times x is 26x. If 26 times x is 26x, then 26x divided by x is 26. That's just the way division works. It's an inverse to multiplication. And then I went and picked up some bad numbers. I think that's going to be 182. Okay. Then I'm subtracting all this. I don't really need these parentheses, but I put them there because I want to think of subtracting all of this, but instead of subtracting it, I distribute the negative sign as I did before. And I do it like this. And now I have negative 5 plus 82, which is negative 177. So I could say my remainder is negative 177. Because if I divide x into negative 177, or divide x minus 7 into negative 177, well, it doesn't work out. Okay. Now, instead of writing remainder negative 177, which is something you are probably familiar with back in the dim recesses of your 5th grade mind, okay? Instead of writing the remainder, I write this as a fraction. And I'm going to say, well, then that's minus 177 divided by x minus 7. But what I've done at each step is I've divided what I've got here by x minus 7, divided by x minus 7 to get this, and so forth. I'm dividing this by x minus 7, so I have this. Okay? Now, that's the mechanics. There are some details. You got to work through the problems to get those details. Okay? Like what happens if one of the variables is missing and so forth. It's something you have to have had in your prerequisite courses. So I'm assuming you have some memory of it. But if not, the open math videos and so forth will show you. And of course, if you come in here and are confused on something, then we'll discuss it. Okay? Now, the last thing I'll tell you about this, with an incidental thing, is okay. What's my graph of x plus 26 look like? Well, y equals x plus 26 has a y-intercept of 0.26 and a slope of 1. It looks like this. This is y equals x plus 26. What does 177 over x minus 7 look like? This is a vertical stretch and a reflection of the 1 over x graph. 1 over x vertically stretched by a factor of 177, then horizontally shifted 7 units. Okay, well, what's the graph of 1 over x look like? It's got an asymptote at x equals 0. So their asymptote's going to be at x equals 7. So I draw the vertical line in here. X equals 7. I draw a flipped reciprocal function, which looks like this. And I add it to this, which is going to give me a function that comes up here and swings back down. And a function that comes down from up here and then swings back up. And notice that's a rational function, and that's kind of the next thing we do after polynomials. So I thought I'd just throw that in since it's a natural extension of what I did with long division. You don't have to do that part, but it's good to write this out and begin thinking about such things.